Welcome to R-OnlineClasses. Hey there, young adventurers. I am your friend, Dr. Frostington. Good ice evening, my chilly scholars. I am Dr. Frostington, your friendly neighborhood penguin professor. Now, let's dive into the frosty depths of knowledge, shall we? Today we will study about density. Density, my frosty friends, is like the scoop-to-cone ratio in an ice cream parlor. Imagine a dense scoop of rocky road, packed with nuts, marshmallows, and existential dread, plopped onto a flimsy cone. That's life, my dear students. Density of a substance is defined as amount of mass per unit of volume of that substance. SI unit of density is kilogram per meter cube, and CGS unit of density is gram per centimeter cube. Conversion is 1 gram per centimeter cube in a 1,000 kilogram per meter cube.
Now time for some penguin puns galore. Why did the penguin bring a ladder to class? Because he wanted to go to high school. Why don't penguins like talking to strangers at the zoo? They find it hard to break the ice. Do remember: 1. The density of a substance does not change with any change in its shape or size. 2. Almost all substances expand on heating and contract on cooling, but their mass does not change. So the density of a substance decreases with the increase in temperature and increases with the decrease in temperature. Exception in water, which contracts on heating 0 to 4 degrees Celsius. So density of water increases from 0 degrees Celsius to 4 degrees Celsius and then decreases above 4 degrees Celsius. And 3. The density of water is maximum at 4 degrees Celsius, which is equal to 1,000 kilogram per meter cube or 1 gram per centimeter cube. You can find the density of irregular solids by using the beam balance to find mass and finding volume by applying formulae of the given 3D shapes like cube, cuboid sphere, and cylinders, etc., then dividing the mass by the calculated volume. And we will do numericals related to this.
Measuring cylinder 1. It is made up of glass or plastic and is graduated in milliliter, ml, with 0 mark at the bottom. 2. The graduations are increasing upwards. 3. We have measuring cylinders available of different capacities, such as 50 milliliters, 100 milliliters, 200 milliliters, 500 milliliters, etc., and 4. The capacity of measuring cylinder is marked on it. Measuring beaker. 1. A measuring beaker is made up of glass, plastic, or metal like aluminium. 2. It is used to take out a fixed volume of liquids, say milk, oil, etc., such as 50 milliliters, 100 milliliters, 200 milliliters, 500 milliliters, 1 liter from a large container. 3. The capacity of measuring breaker is marked on it.
Now time for some penguin puns galore.
Why was the measuring cylinder feeling confident? Because it knew it had graduated. Why did the beaker stop dating the measuring cylinder? It couldn't handle the volume of their relationship. Now let's move to a very special vessel. Eureka can. 1. A eureka can is a glass, or polythene, beaker with a side opening near its mouth, which is known as spout. 2. Thus, the beaker can contain a volume of liquid up to the spout. 3. Any excess of liquid overflows through the spout.
Get ready to rock and density roll, because we're about to find out if this solid has been skipping gym days. Now we will learn how to determine the density of an irregular solid. Way to go! First, find the mass using a spring or beam balance. Next, fill the cylinder just a bit to mark where the water sits. Note it as V1. Tie the solid, nice and neat, lower it down without a beat. Splash not, we're almost there. Note the level with great care. V2 subtract the volumes. V2, V1, that's our volume in ml. Now, divide the mass you found by the volume that's profound. Here's the formula: density mass upon volume. And voila, you've got it right. The density's in plain sight. Write the unit correctly. Let's move to next concept abruptly. How to find density of an irregular solid using a Eureka can. Dry the solid, don't let it soak, measure its mass. It's no joke. Let's say it's 300 grams, not too heavy, not too light, just like a jam. Fill the can to the brim, let it overflow on a whim. Wait for the drip drip to stop, then off the cylinder you pop. Tie the solid, let it take a dip into the Eureka can, it'll make a trip. Displace the water, watch it rise, collecting in the cylinder, no surprise. Note the volume, how much it grew, that's the clue for step 2. Calculate the density, don't be tense, it's just a matter of common sense. Density equals mass over volume. Let's say V is the volume of water collected in the measuring cylinder, 100 centimeter cube. M is the mass of the solid, 300 gram. So the density of our irregular solid is density equals mass over volume. Hence, 300 over 100 is 3 gram per centimeter cube. Now you've got the density, and it wasn't even messy. Determination of density of a liquid. To determine the density of a liquid, milk or oil, etc., its mass M is measured by a common beam balance, and its volume V is measured by a measuring cylinder. Then density is calculated by using the relation D equals mass over volume, which comes in gram per milliliter. Density bottle. Density bottle is specially designed bottle which is used to determine the density of a liquid. It is a small glass bottle having glass stopper at its neck. The bottle can store a fixed volume of a liquid. Generally, the volume of bottle is 25 milliliters or 50 milliliters. The stopper has a narrow hole through it. When the bottle is filled with the liquid and the stopper is inserted, the excess liquid rises through the hole and drains out. Thus, the bottle contains the same volume of liquid each time when it is filled. Since the density of water is 1 gram per milliliter, so the mass in G of water needed to fill the bottle completely will give the volume in ml of the bottle. Nowadays, it is named a specific gravity bottle. Relative density. The relative density of a substance is defined as the ratio of the density of the substance to the density of water at 4 degrees Celsius. RD is density of the substance over density of water at 4 degrees Celsius. There once was a penguin named Frost, whose lectures were never a loss. He taught with such flair, science filled the air, and left us all craving for more of the gloss. So tap that like, hit subscribe. For part 2, you'll want to imbibe. Share with your mates, for knowledge awaits on R-OnlineClasses. Join the tribe. Da-da.